Hi, this is Shawn Smith, and this is my video project for Physics 3030. I decided to do my project on the CMB, the cosmic microwave background, and the best way to explain what it is to explain where it came from. So to look at where the CMB came from, we need to look at the universe about 380,000 years after the Big Bang. We have this cool picture here. Obviously, I didn't make this. It's from earthsky.org. But we look at this arrow right here, and it actually shows a picture of the CMB. Now, leading up to this point in the universe was much smaller and much hotter. The temperature was so extreme that any matter that existed in particles. The extreme heat made it so that none of these particles could form into any kind of atoms. Basically, the only thing that existed was this opaque soup of particles floating around and bumping into each other. And within this particle soup, there was also a huge amount of photons, which were just bouncing around with the protons and electrons and whatnot. And the fact that this soup or plasma was opaque means that the photons didn't have anywhere to go. Opaque means light cannot shine through, so the particles of light were basically trapped. Now, what happened was, as the universe expanded, this particle soup began to cool off, and as it cooled, it began to allow these particles to combine and form atoms, which then allowed for the formation of hydrogen. And this basically means that all of those photons no longer had anything in their way, and they were free to shoot out through the distance of the known universe. So as things cooled off, the universe went from being opaque to transparent, and it was like billions of flashes going off in all directions. We have this cool picture that kind of shows the particle soup here, the formation, and the photons escaping. And the most amazing part is these photons are still around, and they are what make up the CMB. Now, of course, we don't look out into the night sky and see these glowing photons, although that would be pretty incredible, but we don't see it because over all this time, these photons have redshifted into the microwave band of the electromagnetic spectrum, so they're invisible to us. So this is the WMAP picture of the CMB, and this is actually what's surrounding us from our viewpoint here on Earth. And what it shows is the variations in temperature, mostly due to interference from the photons that we're looking at. The CMB actually maintains 2.7 Kelvin. So that's the CMB. I find it pretty fascinating, and it's a huge deal because it corroborates the idea of the Big Bang, and that is huge. Anyway, that's my explanation. It's been a good semester. I've learned a lot, and I hope you guys liked the video.